Okay, what I've noticed is a lot of students have issues with this problem here about what the points are in the problem of interest. And I'm looking at it, I kind of see the curve, and a lot of students look at this and they don't know what the points are. And I'll put the points down for you. I'm going to say it looks like the points here, 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 and here. All right, so what are those points over there? I want to point out they're not difficult to compute. So let's just take one of those. And what I want to do is I want to take the point where y is equal to 0. And if I did that, what would you get? You would get x to the 2/3 equals 5 to the 2/3. Well, what's that going to be? Well, let's look at it. It's got to be 5. So I'm seeing that right over here. All right? Now, certainly, we hope you realize that that's obvious over there, that that's going to be the point 5 comma 0. But there's another point over here. And this makes sense, too, because you could have used minus 5, because when squaring it, you still get the same result. So I can say minus 5, 0. Right, I hope you start to realize you could also set x to the 0, you get the same story. This would going to be 0 minus 5, and this point over here would be 0, 5. So the next thing I want to recommend to you is that you notice that each one of these sections here appears to be really the same. All right, what I mean by that, the length of those is the same. They're all the same. So we just got to do one. Question is, which one do you want to do? Well, I'm going to pick the one in the first quadrant. So let me get my eraser out, and I'm just going to stick around the first quadrant. All I'm going to do, the first quadrant. Let me erase this business over here, and I want to do it. Right? So how would you do that? And I guess I got to do something, right? So let's write this down, and I'm going to say, let's just take a look at it. I'm going to start to differentiate it. So you get 2/3. And then you would get x. I got to reduce it by 1/3, so that's minus 1/3. Let's see, that would be dx. All right, then I get plus. I'm doing implicit differentiation. 2/3. Y, I'm going to reduce it by 1, so that's going to be minus 1/3. And now I get the dy dx. Take your derivative of the right-hand side, that's 0. That's pretty convenient. And what do you get? Let's write this down. dy dx would be equal to, well, let's write this down carefully. It's minus 2/3 x to the minus 1/3 divided by 2/3 y to the minus 1/3. Well, I'm going to reduce that. And, I certainly get a negative. And what else do you get? Well, I'm going to say y to the 1/3 over x to the 1/3. All right? So what do I got to do with that? I got to square it, add 1 to it. Let me write that down for you. So 1 plus dy dx squared. Let's write that. That's 1 plus, that will be y to the 2/3 and x to the 2/3. Well, I'm going to still simplify that. That's x to the 2/3. And you would get x to the 2/3 plus y to the 2/3. And that's sort of recognizable. I've seen that before. And the top is just simply 5 to the 2/3. So what I'm going to do now, I'm going to set the integral up. And before I do that, I want to do the square root of it. Now, by the way, I'm in the first quadrant. I hope you realize that everything's positive there. So let's write this down. It's going to be from, I'm going along the x's, by the way. I'm going to start at 0, go to 5. This thing turns out to be pretty simple. It's 5 to the 1/3, and the bottom is x to the 1/3. I'm going to write that a little differently. I'm going to write it as the cube root of 5 times x to the minus 1/3. So let's put this is going to be the arc length. I'm going to put down that this is going to be the cube root of 5. I'm going to get my eraser out. You need a little more room. And I'm going to say the arc length over here, I'll just call it S, is going to be the cube root of 5. That's a constant being pulled out. We're starting at 0. We're stopping at 5. And then I get x to the minus 1/3 dx. I think I can do the integration. And what do you get over there? Let's write this down. S equals the cube root of 5. I'm gonna add 1 to minus 1/3, so 2/3. And then I'm gonna divide by 2/3 and multiply by 3/2. Whoops, sorry about that. Jumped the gun there. So I'm gonna multiply by 3/2. And the limits of integration are gonna be from 0 to 5. Let's write that down. And what do you get there? S equals the cube root of 5. You get a 3. You get a 2. And then I gotta do this, it's 5, right? To the 2/3 power. And 2/3 power means really the cube root of 5 squared. Well, I think I can continue with that. And then what do I see? I see 3 and I see a 2. And the cube root, well, that would be 5 cubed, right? And what do you get there? Let's see, 3 times 5, which is 15 over 2. All right? Now, we haven't looked at the key yet. And as soon as I forget what you just did, they want to calculate the length. And I hope you realize I just did only 1 out of the 4. So what's the length going to be? Let's write this down. The length of that object we just looked at is 4 times 15 over 2, which is going to be 30. All right, let's look at the K, see how we did. And I see it right over here. Now, granted, there's a lot of work down over there. You may be looking at the work, you may not be looking at the work. What you may be doing is just simply doing the work yourself and verifying an answer. I will say this, though. It's important you start to look at work, all right? Why do you look at work? You really want to compare your work to somebody else's work, all right? Now, what I mean by that, when I'm doing these problems sets, what I do is I do the problems like I do over here, a piece of paper. And then what I do is I try to type it up nice and neat, right? And I go through those steps in a neat way and organized way. And it's really the same thing. And I try to make it coherent, all right? So in the blue area, it's a more linear fashion of what my work would look like. When I do the chicken scratch dough, it's kind of all over the place. Thank you.